Okay, this is a question from a recent exam. Okay, 9709 Pure 1. Okay, so the rest of the question, we have 6 questions over here. All these 6 questions are from 9709. Okay, so let's have a look at the first one. Okay, 4 plus ax. You have to find the coefficient, the coefficient of x squared is 3 when they multiply 4 plus ax with 1 plus x over 2 to the power of 6. Okay, when they expand, the coefficient of x squared is 3. So find the value of the constant a. Okay, let's do that. So expand as usual. 6c0, 1 to the power of 6, x over 2 to the power of 0, plus 6c1, 1 to the power of 5, x over 2 to the power of 1, 6c2, 1 to the power of 4, x over 2 to the power of 2, plus 6c3, 1 to the power of 3, x over 2 to the power of 3. Okay, if I expand this, okay, use your calculator. Okay, and you should get 6c0, which is 1. Then the next one, 6c1, which is 6 times by x over 2, plus 6c2, 15, x squared over 4, plus 20 times by x cubed over 8, then plus ... Okay, now I'm not done yet, so I'm going to take the next part is, since you need to expand, you take 4 plus ax, and then you multiply by 1 plus 6 over 2, which is 3x, okay, plus 15 over 4 x squared, plus, let's divide by 4, 2 x cubed, and 5. All right, that was 4, 2 times 4. Okay, then plus ... Okay, now expanding this to find the coefficient of x squared. Okay, coefficient of x squared, which 2 will give me 4 times by 15 over 4. So 4 times by 15 over 4 x squared, and then plus ax times by 3x. Yeah, ax times by 3x, and this is equals to 3, the coefficient of x squared. So this is equals, I'm going to write 3x squared. Okay, let's simplify this. So that those two gets cancelled. 15x squared plus 3ax squared equals to 3x squared. 15 plus 3a x squared equals to 3x squared. So now we just have to compare. We have already factorized and taken out x squared separately. So let's compare. So I'm going to do it over here. So 15 plus 3a equals to 3. Okay, so 3a equals to 3 minus 15. So 3a equals to 12 minus 12, and a equals to -4. Okay, next, a woman's basic salary for her first year with a particular company is 30,000, and at the end of the year she also gets a bonus of 600. For her first year, express a bonus as a percentage of her basic salary. Okay, that's quite simple, 1 mark. Okay, her bonus as a percentage of basic salary. What's her basic salary? 30,000. Okay, her basic salary is 30,000, and then her bonus is 600. Okay, so express a bonus as a percentage, so you just have to divide, okay, and then multiply this by 100, and from here we get the answer as 2%. Okay, very straightforward. Okay, next, at the end of each year the women's basic salary will increase by 3%. Okay, anything that increase every year by 3% or any number of year. This is it's not arithmetic, it is geometry progression, GP. Okay, not AP. Okay, it is GP. Okay, immediately you should know, because every year there's an increase by 3%. So 3 over 100, which is 0.03. okay, you add this by 100 over 100, which gives you 1. So this is your multiplier. Okay, this is also known as your multiplier. Okay, now let's look at what is the question wants. Okay, express the bonus she will be paid at the end of her 24th year as a percentage of basic salary paid during that year. Okay, let's do this. Okay, now 100% is she gets, okay, first of all, her bonus is 600. Okay, and then the women's basic salary will increase by 3, and her bonus will increase by $100. Okay, every year she gets increased by $100. So, and then on her end of 24th year. Okay, so let's figure this out. So first year she gets $600. Okay, and then at the end of 24th year, how much will she be getting? Okay, on the first year, let's say she has started on the first year, so by end of first year her bonus is 600, but on the 24th, meaning she has worked another 23 years, so it should be 23 times by $100. Okay, so that is $2,300. Okay, so every year an increase of $100 will give $2,300 by end of 23 years of service, but by then she has worked for 24 years. So by end of 24 years she will be getting bonus alone $2,600 plus 2,300, which is 2,900. Okay, and then how much, express the bonus she will be paid at end of 24th year as a percentage of her basic salary. Now let's find out what is her basic salary by end of 24th year. So first year she earns 30,000. Okay, that's her basic salary. And after that, how many years that she has been working to get to 24th year? She has been working for another 23 years. Okay, so use your calculator. And your answer is 59207.60. Okay, so now percentage, express the bonus as a percentage of basic salary. So her bonus is 2,900. Divide this by 59207.60, and then you times this by 100, and getting this as 4.89, which is same as 4.9%. Okay, the common ratio of geometry progression is r. The first term of progression is r square minus 3r plus 2, and the sum to infinity is s. Show that s equals to 2 minus r. Okay, 2 marks, so I don't think so you'll have a lot of working over here. So let's find out. First of all, the formula for s infinity, or sum to the infinity. Okay, sum to infinity is a over 1 minus r. Okay, a over 1 minus r, provided your r value, okay, your modulus r is less than 1. What does that mean? Okay, that means your r value is between -1, okay, less than r, less than 1. Okay, for summation series or geometry sequence to have a limit, okay, when they sum to infinity, if there's a limit, okay, limit partly means that, you know, when we add a successive term, we are adding, and it's not enough to reach a certain limitation, okay, then your R value has to have a range, okay. The range is given between -1 to +1, your R value. So when there's a limit, okay, we say that the sum to infinity exists, okay, in this case. So whereby your R must be within -1 to +1, okay. That's when your sum will converge, okay. So I mean, you will learn this more in detail if you do further, okay, but we are not going there. I don't want to go too in detail, just understand the formula. So make sure for sum to infinity, okay, of a series, okay, there will be a limit. If there's a limit, then your R must be between -1 to +1. Okay, let's have a look at the question here. So what is R is less than 1? So in this case, the formula says your first term is R square minus 3R plus 2 over 1 minus R, okay, 1 minus R, and this is equal to 2 minus R, right? Okay, because it's given here, 2 minus R. So let's sort this out. So if I think that's R minus 2 and R minus 1 over 1 minus R, which I can write as negative 1 minus R minus 2 equals to 1 minus R, right? Because this one, okay, R minus 1, and I take out the negative, I can write it as 1 minus R, so that I can simplify. So when I simplify this, I will get negative R minus 2, which is negative R plus 2, which is same as 2 minus R. Okay, so that's okay. This is shown, you can see here, that's shown. Okay, those two values are shown. Okay, now find the set of possible values that S can take. Okay, find the set of possible value that S can take. So for this is where you have to consider your R value. Over here it's given 2 minus R. I'll just take this and sub inside. So -1, so your R value to have set of range for S, so your R value should be between -1 less than R, okay, and then less than +1. Okay, so what's your R? Okay, it's given as 2 minus R. Okay, it's given as 2 minus R. So -1 less than 2 minus R. Oops. Less than 1. So if I want to find, I can break this -1 less than 2 minus R, and 2 minus R is less than 1. So -1 minus 2 is less than -R, then -3 is less than -R, and 3 is greater than R, or R is less than 3. Okay, that's the first part. And then -R is less than 1 minus 2, so -R is less than -1, so R is greater than 1. So your range of R value that can, which you can take to make this as possible is 1 is less than R, R is less than +3. That's it. The coefficient of 1 over x in the expression of 2x plus a over x squared to the power of 5 is 720. Find the possible values of the constant a. Okay, let's every time when I get a question like this, I will expand to a certain extent. You don't have to do all, but to a certain extent until you can get the answer. Okay, so first 5c0 is 2x to the power of 5, and then a over x squared to the power of 0. Okay, they want the coefficient of 1 over x. I don't think so. I'll get it over here. And then plus 5c1 2x to the power of 4 a over x squared to the power of 1. Okay, so if you look at it, that's x squared, that's x to the power of 4. So when you cancel those, okay, irrespective whatever your value of 5c1, okay, you don't have to worry about that. I don't think so you can get that. You still have x squared on top as a numerator, not the denominator. Okay, so I can go for one more, 5c2. Okay, 5c2 2x to the power of 3, and at the bottom you have a over x squared to the power of 2. Okay, so when I do that, that's 2x cubed. Okay, so you will get that as 2x cubed, or sorry, 8x cubed, and then a square over x to the power of 4. So what you have here is 8x 5c2 multiplied by 8x cubed times by a square over x to the power of 4. There you go. Okay, so cube. So this is the term that I want. So let's write that here. So 5c2 8x cubed multiplied by a over x to the power of 4, and 5c2 will give us 10 times by 8, and these two gets cancelled, 8a over x. So sorry, a square. Okay, that's square over here, so should give me 80a square over x. 80a square over x is equal to since it says 1 over x, coefficient of 1 over x squared, so I'm going to write this as 720 over x. Yeah, okay, so from here we can figure out what is a. So if I take out the x, so that's 80 a square equals to 720. So a square equals to 720 divided by 80, which is 9. So a equals to square root of 9, which is plus minus 3. Okay, possible values, so you already have those two values. Okay, hence find the coefficient of 1 over x to the power of 7 in the expansion. Okay, 1 over x to the power of 7. Okay, we have seen here, this is x cubed, this is x cubed, that's x squared. So the denominator over here is x to the power of 4. When I expand a over x square, square that, you get a square over x to the power of 4, and that is x cubed. So we know we are not getting, we are only getting 1 over x. What about the next one? If I go to the next one, it is 2x to the power of, what is that, 2. So 2x to the power of 2, and then that would be a over x squared to the power of 3. So even if it's 3, that's square, this is to the power of 6. So we are not getting 2x squared over x to the power of 6, which gives me x to the power of 4, 1 over x to the power of 4. So let's look at the next one, 5c4. 5c4, if I do 5c4, I'm getting 2x to the power of 1, and then multiply this by a over x squared to the power of 4. When I do that, certainly this is 1 and that's x squared. Okay, so what am I getting? Okay, so 5c4, which is 10. Okay, we'll just do, sorry, it's 5, not 10. Okay, times 2 will give you 10. Okay, so 5c4 is 5 times by 2x, and then times by a to the power of 4 over x to the power of 8. So this is 10x a to the power of 4 over x to the power of 8. When I cancel, I'll get 10 a to the power of 4 x to the power of 7, and hence find the expansion of in this. Okay, so since a is positive and negative, so it doesn't matter what you plug in because it's to the power of 4. So 10, so I'll just write it as positive to the power of 4 over x to the power of 7. So that's 81 times 10, which is 810 over x 7. So coefficient oops, wrong, coefficient of 1 over x to the power of 7 is 810. In the expansion of 1 over ax plus 2ax squared to the power of 5, the coefficient of x is 5. Find the value of the constant a. Find the value of constant a. Okay, let's expand. Coefficient of x, so 5c0. Okay, oops, right here. 5c0, 1 over ax to the power of 5, and 2a x squared to the power of 0 plus 5c1, 1 over ax to the power of 4, 2x squared to the power of 1 plus 5c2, okay, 1 over ax to the power of 3, 2ax squared to the power of 2, 5c2. Okay, so which one will give you, yeah, so that is what will give me x, because that's 1 over a cube x cube, and then that is 4a square x to the power of 4. There you go. So that's cube, and then when you cancel you get just x. Okay, let's just take that. Okay, let's just take that. So there should be 5c2, so it's 1 over a x to the power of 3 multiplied by 2a x squared to the power of 2, and this gives me 10 times by 1 over a cube x cube times by 4a square x to the power of 4. Okay, so when you expand 10 times by 4, which is 40 a square x to the power of 4 over a cube x cube, and that should give me, that gets cancelled, so what's left is just a at the bottom, and what's left on top is 40x. Okay, so the coefficient of x equals to 5. So 40 over a equals to 5. From here we know a equals to 40 divided by 5, which is positive 8. Next, an arithmetic progression. AP as a first term, a equals to 32, and then the fifth term equals to 22. So fifth term, so t5 equals to 22, and then the last term, okay, last term equals to negative 28. Okay, so t5 equals to a plus 4d. So 22 equals to 32 plus 4d. Okay, let's find what is d. So this should be 4d equals to 22 minus 32. d equals to negative 10 over 4, which is negative 5 over 2, or negative 2.5. Next, it's given that last term is negative 28. I don't know how many terms are there, but the last term is negative 28. So let's find out how many terms. So t n equals to a plus n minus 1 d. So the last term is negative 28. okay, the term value is negative 28, a equals to 32 plus, I don't know n because that's the last term, so n minus 1 times by negative 2.5. okay, so now just expand this, so you get negative 2.5 times n and then plus 2.5 equals to negative 28 minus 32. Is that right? Yeah. Okay, negative 2.5 n equals to negative 60 minus 2.5. So n equals to negative 62.5 divided by negative 2.5. okay, and the answer is 25. Okay, next, each year a school allocates a sum of money for the library. The amount allocated each year increases by 2.5. Again, anything that increases every year, okay, it is AP or GP depending on the question. The sum increases by 2.5 amount allocated by previous years. So in 2005 the school allocated 2000. Find the total amount allocated in the years between 2005 to 2014 inclusive. Oh, sorry, I haven't not finished the sum of the term. Okay, I'm not done yet, so let's finish this. So this is find the sum of all the terms in the progression. So that's quite simple, as n equals to n over 2a plus n minus 1 and then times d. So this should give you have how many terms there? 25 terms, okay, over 2, and then 2 times a, okay, a is 32, okay, and then plus you have n minus 1, so 25 minus 1, which is 24 times by negative 2.5. okay, use your calculator. Okay, from here I got my answer as 50. okay, let's go to B. Okay, so this looks like it increases by 2.5 every year. Okay, amount allocated every year, so certainly this is geometry progression. Okay, so GP not AP. Okay, so let's figure that out. So amount increases by how many percent? 2.5%. so 2.5% plus 100, which is 102.5%, and find the multiplier. So this should be 1.025. okay, that's your multiplier. Okay, so the question here is, what is the total amount allocated in the years 2005 to 2014 inclusive? 2014 inclusive, remember. Okay, so how many years is that from 2005 to 2014? It's not 9 years because you got to include 2014 as well. So from 2005 you take 2005, 2006, 2007, 2008, 2009, 2010, 11, 12, 13, 14, 10 years. Okay, so 10 years. Okay, so 10 years, so S10 equals to a times r to the power of n minus 1 over r minus 1. Okay, this is not sum to infinity, they just want a particular number of years, which is 10 years. So use the formula 2000 times by your multiplier 1.05 to the power of 10. The multiplier over here is the number of years. Okay, what is the increase? Basically the ratio. Okay, you're just finding the ratio. So 1.025 minus 1, and then this is using calculator. I got the answer as 22,400. Okay.